بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه وسلم تسليما كثيرا. أما بعد، أبنائي الطلبة والطالبات، السلام عليكم ورحمة الله وبركاته. بيسعدني أني ألتقي بكم في أول محاضرة لنا عبر شبكة الإنترنت في استكمال لمنهجنا في مقرر Principle of Statistics. طبعا احنا انتهينا من section 2.5، ده كان قبل امتحان أعمال السنة الأول، ودي هتبقى أول محاضرة لينا بعد امتحان أعمال السنة الأول. أرجو من الله إن شاء الله أن يكون المحاضرات ديت وسيلة بتساعدكم خلال الفترة القادمة دهيت على فهم الدروس، وبحاول إن أنا أبسط على قد ما أقدر بحيث توصل لكم المعلومة زي ما كنا موجودين مع بعض في قاعة المحاضرات. وإن شاء الله we'll start with section 2.6 named numerical measures of relative standing. We have seen that numerical measures of central tendency and variability describe the general nature of a qualitative data set, either a sample or a population. In addition, we may interested in describing a relative quantitative location of a particular measurement within a data set. Descriptive measures of the relationship of a measurement to the rest of the data are called measures of relative standing. One measure of the relative standing of a measurement is its percentile ranking. هنركز على البرسنتايل أو بنسميها المئينات or percentile score. For example, suppose you scored an 80 on a test and you want to know how you fared in comparison with other in your class. يعني لو في أحد الاختبارات أنت حصلت على درجة 80 من 100 وعايز تشوف أنت ترتيبك إيه بالنسبة لزمايلك في الفصل، فبنقول مثلا if the instructor tells you that you scored at the 90th percentile، يعني انت الدرجة اللي حصلت عليها اللي هي ال 80 من 100 دي، ال 80 من 100 دي بيقول لك ان هي scored 90th percentile، يعني هي بتقع عند النسبة 90% او البرسنتايل 90%. It means that 90% of the grades were lower than yours and 10% were higher. يعني لما بنقول انك الدرجة اللي انت حصلت عليها بتقع عند البرسنتايل ال90 او ال90، ده معناه ان الدرجة اللي انت حصلت عليها اللي هي 80 دهيت، دي درجة حصل 90% من الطلاب على درجة أقل منها، وحصل 10% من الطلاب على درجة أعلى منها. Thus, if the scores were described by the relative frequency histogram, as we see in this figure 226, the 90th percentile would be located at the point such as 90% of the total area under the relative frequency histogram lies below the 9th percentile and 10% lies above. يعني لما بنشوف مع بعض الدرجة اللي انت حصلت عليها ديت ال80، لو بقول الدرجة ده هي او اللوكيشن ده، خلي بالكم بنتكلم هنا على اللوكيشن، اللوكيشن ده هو ال9th percentile. طيب معنى كده ان اللوكيشن ده لو انا جيت اشوف في عندي كام ستودنت جاب درجة أقل من الدرجة دي، أو لو أنا جيت أشوف الفريكوانسيز اللي هي التكرارات اللي موجودة عندي أو الريلاتيف فريكوانسي زي ما هو ظاهر عندي في الرسم، لو أنا جيت أشوف الريلاتيف فريكوانسي هنا هلاقي إن مجموع الريلاتيف فريكوانسي قبل الدرجة دهيت ده بيمثل 9/10.9، واللي بعد الدرجة ديت ده بيمثل 1/10 اللي هي 10 percentile بعد و90 percentile قبل الدرجة. فعشان كده بسمي اللوكيشن ده أو الدرجة ده إيه؟ بسميها 9th percentile. If the instructor tells you that you're scored in the 5th percentile، طبعا احنا عارفين ان الفيفث برسنتايل ده اللي هو اللوكيشن بتاع الميديان. طيب يبقى معنى الكلام ده ان 50% of the test grades would be lower than yours and 50% would be higher. كده معنى الكلام ده ان احنا بدل ما بقول لك انت لو انت حصلت على 90% او الناينث برسنتايل، لو انا قلت انك انت الدرجة بتاعتك موجودة عند الفيفث برسنتايل، فمعنى كده ان درجتك في قبليها 50% من الدرجات او قبليها نص ل5/10 relative frequency وبعديها 5/10 relative frequency. So to summarize what we just said, احنا لما بيبقى عندي مجموعة من درجات الستودنت مثلا في احد الاختبارات وبرتب الدرجات دهيت ترتيب تصاعدي ascending، تمام، وعايز اشوف اللوكيشن بتاع الدرجة بتاعتي موجودة فين بالنسبة لباقي الستودنت. فلو الدرجة بتاعتي لقيت ان قبليها 50% of student وبعديها 50% of student، يبقى انا مكاني ال 50% ده احنا بنسميه الايه؟ الميديان، الوسيط موجود هنا، تمام. لما بقول ان اللوكيشن بتاعي عند ال 60%، فده معناه ان الدرجة اللي انا حصلت عليها في قبليها relative frequency او قبليها درجات طلاب يمثلوا 60% من طلاب المجموعة بتاعتي، وبعد الدرجة بتاعتي في 40% من طلاب المجموعة أو الفصل اللي أنا موجود فيه. So we define the P percentiles of a data set as follows. For any set of n measurements arranged in ascending or descending order, the B's percentile is a number such that P% of the measurements fall below the number and 1 minus P% fall above it. In example 214, refer to the water level task deviations for the 40 subject in table 2.4. An SPSS printout describing the data is shown in figure 227 as we see together. Locate the 25th percentile and 95th percentile on the printout and interpret the associated value. Both 25th percentile and 95th percentile are highlighted on the SPSS printout. The values in question are 2 and 24.8 respectively. Our interpretations are as follows. 25% of the 40 deviations fall blue 2 and 95% of the deviations fall blue 24.8. Percentiles that partition a dataset into 4 categories, each category containing exactly 25% of the measurements are called quartiles. The lower quartile, QL, is the 25th percentile. The median quartile, M, is the median or 5th percentile, and the upper quartile, QU, is the 75th percentile, as shown in figure 228. Therefore, in example 214, we have QL equal to M, or the median, equal 7, QL upper quartile, QU equal 10. This is the 3 quartile that divided our data or partition our data to 4 quartiles. So now we can say this definition. The lower quartile QL is the 25th percentile of a data set. The middle quartile M is the median or 50th percentile. The upper quartile QU is the 75th percentile. Another measure of relative standing in popular use is a z-score. As you can see in the following definition, the z-score makes use of the mean and standard deviation of a data set in order to specify the relative location of the measurements. So, the sample z-score for a measurement X is Z equal X minus X bar divided by S. But in population, z-score for a measurement X is Z equal X minus mu divided by sigma. Note that the z-score is calculated by subtracting X or mu from the measurement X and then dividing the result by S or sigma. The final result, z-score, represents the distance between a given measurement X and the mean expressed in standard deviation. The numerical value of the z-score reflects the relative standing of the measurement. A large positive z-score implies that the measurement is larger than almost all other measurements, whereas a large negative z-score indicates that the measurement is smaller than almost every other measurement. If a z-score is 0 or near 0, the measurement is located at or near the mean of the sample or population. We can be more specific if we know that the frequency distribution of the measurements is mound-shaped. In this case, the following interpretation of the z-score can be given. Interpretation of z-scores for mound-shaped distribution of data. First, approximately 68% of the measurements will have a z-score between minus and positive 1. 2. Approximately 95% of the measurements will have a z-score between minus and positive 2. 3. Approximately 99.7%, almost all, of the measurements will have a z-score between minus and positive 6. Note that this interpretation of z-score is identical to that given by the empirical rule for mound-shaped distribution. The statement that a measurement falls into the interval from mu minus sigma to mu plus sigma is equivalent to the statement that the measurement has a population z-score between minus and positive 1, since all measurements between mu minus sigma and mu plus sigma are within one standard deviation of mu. These z-scores are displayed in figure 230. Section 2.7 named Methods for Detecting Outliers, Box Plots, and z-score. Sometimes it's important to identify inconsistent or unusual measurements in a data set, and observations that is usually large or small relative to the data values we want to describe is called an outlier. Again, an observation or measurement that is usually large or small relative to the other values in a data set is called outlier. Outliers typically are attributable to one of the following causes. 1. The measurement is observed, recorded, or entered into the computer incorrectly. 2. The measurement comes from a different population. 3. The measurement is correct, but represents a rare event. Two useful methods for detecting outliers, one graphical and one numerical, are box plots and z-scores. The box plot is based on the quartiles defined in section 2.6 of the data set. Specifically, a box plot is based on the interquartile range. The interquartile range is the distance between the lower and the upper quartile. It means interquartile range equal QU upper quartile minus QL lower quartile. Recalling the gas mileage data, a Minitab box plot is shown in figure 231. Note that the rectangle or this box is drawn with the bottom and top of the rectangle, the hinges drawn at the quartile QL and QU respectively. Recall that QL represent the 25th percentile and QU represent the 75th percentile. By definition, then the middle 50% of the observations, and this is the median, those between QL and QU fall inside the box from the gas mileage data. These quartiles are at 35.625 and 38.375. Thus, interquartile range equal 38.375 minus 35.625 equal 2.75. The median is shown at 37 by horizontal line within the box. To guide the construction of the tails of the box plot, two sets of limits called inner fences and outer fences are used. Neither set of fences actually appears on the plot. Inner fences are located at distance of 1.5 interquartile range from the Higgs. This to Higgs. We scale 1.5 from lower Higgs and 1.5 interquartile range from upper Higgs. Emanating from the hinges of the box are vertical lines, these two vertical lines, called the whiskers. The two whiskers, this and this, extend to the most extreme observation inside the inner fence. For example, the inner fence on the lower side of the gas mileage box plot is equal lower hinge minus 1.5 interquartile, that will be 31.5. we are not drawing the point 31.5 here. The smallest measurement inside this fence is the second smallest measurement, 31.8. Thus, the lower whisker extends to 31.8. Similarly, the upper whisker extends to 42.1, the largest measurement inside the upper inner fence. Upper inner fence will equal upper hinge plus 1.5 interquartile will equal 42.5. Also, this point is not drawn here. Values that are beyond the inner fences are deemed potential outliers because they are extreme values that represent relative rare occurrences. In fact, for mount-shaped distribution, less than 1% of the observations are expected to fall outside the inner fence. Two of the 100 gas mile age measurements, 30 and 44.9, fall beyond the inner fence, one on each end of the distribution. Each of these potential outliers is represented by a common symbol, asterisk, like we see this asterisk and this one. The other two imaginary fences, the outer fences, are defined at a distance 3 interquartile range from each end of the box, from each end here and there. Measurements that fall beyond the outer fence, also represented by an asterisk in Minitab program, are very extreme measurements that require special analysis. Since less than 0.01%, it means 0.01% of the measurements from mount-shaped distributions are expected to fall beyond the outer fence, these measurements are considered to be outliers. Because there are no measurements of gas mile age beyond outer fences, there are no outliers. Now you can check by yourself in this box elements of box plot. You can pause the video and read these notes. This is about what we just explained now. Also this box. So we summarize what we just say in these two boxes. In example 218, suppose a female bank employee believes that her salary is low as a result of sex discrimination. To substantiate her belief, she collects information on the salaries of her male counterparts in the banking business. She finds that their salaries have a mean of $64,000 and a standard deviation of $2,000. Her salary is $57,000. Does this information support her claim of sex discrimination? The analysis might proceed as follows. First, we calculate the z-score for the woman's salary with respect to those of her male counterparts. Thus, z-score will equal woman's salary 57,000 minus male mean $64,000 divided by the standard deviation 2000, that will equal minus 3.5. The implication is that the woman's salary is 3.5 standard deviation below the mean of the male salary distribution. Furthermore, if a check of the male salary data showing that the frequency distribution is mound-chipped, we can infer that very few salaries in this distribution should have a z-score less than minus 3, as shown in figure 234. Clearly, the z-score of minus 3.5 represent an outlier, as we see. Either her salary is from a distribution different from the male salary distribution, or it is a very unusual measurement from a salary distribution no different from the male distribution. Which of the two situations do you think it done? Statistically thinking would lead us to conclude that her salary does not come from the male salary distribution, leading support to the female bank employees' claim as sex discrimination. However, the careful investigator should require more information before inferring the sex discrimination is the cause. We would want to know more about the data collection technique the woman used, and more about her competence at her job. Also, perhaps other factors such as length of employment should be considered in the analysis. We conclude this section with some rules of thumb for detecting outliers. Box plot: observations falling between the inner and outer fence are deemed suspect outliers. Observations falling beyond the outer fence are deemed highly suspect outlier, as we've seen here. Z-score: observations with Z-score greater than 3 in absolute value are considered outlier. For some highly skewed data sets, observation with z-score greater than 2 in absolute value may be outlier. بكده أعزائي الطلاب نكون انتهينا من section 27. section 28 ده section optional ومش داخل معانا في المنهج بتاعنا، ولكن section 28 ده هنعامله نفس معاملة السكشن الأخير في chapter 1. كنت سبت لكم آخر section في chapter 1 ده كنتوا انتوا مطلوب منكم reading له وإن هو جزء من منهجنا، وطلبت منكم إن كنتوا بتحاولوا تقروه وتحاولوا إنكم تفهموه بنفسكم كنوع من الهوم وورك. نفس الشيء عندنا سيكشن اللي هو 29، هو ده السيكشن الثاني اللي انا اتفقت عليكم هيبقى فيه سيكشنين في منهجنا، هتقروهم بنفسكم وهيكونوا موجودين معانا في المنهج، اللي هو بعنوان Distorting Truth with Descriptive Statistics. وبكده نكون انتهينا من chapter 2 ومن محاضرتنا الأولى أونلاين مع بعض، وإن شاء الله أنتظركم في المحاضرة التالية، والسلام عليكم ورحمة الله.